Welcome, everyone. Thank you for joining us today. My name is Vijay Abraham. I'm the head of the Center for Interdisciplinary Digital Research at the Research Data Services Unit at Stanford Libraries. I'll be introducing our topic, the project team, and give a quick overview of our presentation today. Our project draws from the field of cultural analytics, whereby computational methods are applied to the study of cultural heritage. We will discuss our exploratory work in bringing machine learning techniques to the study of theater performance, and in particular, directorial style. The project, titled Machine Intelligence for Motion Exegesis, or MIME, is the result of a collaboration between Assistant Professor Michael Rao and the developer team at Research Data Services. That team consists of myself, and more importantly, Peter Broadwell and Simon Wiles. You'll hear from all of us over the duration of this talk. Michael Rao is Assistant Professor of Theater and Performance Studies, as well as an affiliate faculty member at HAI here at Stanford University. He received an MFA in directing from Columbia University and has directed works internationally, including plays, operas, and digital media projects. He's been featured in the New York Times, The Guardian, and The Telegraph, and was the recipient of a 2021 Artists plus Machine Intelligence Research Award from Google. Peter Broadwell is one of the two digital scholarship research developers at RDS, where his work applies machine learning, web-based visualization, and other methods of digital analysis to complex cultural data. He has a PhD in musicology from UCLA and an MS in computer science from UC Berkeley. Simon Wiles is the other digital scholarship research developer on the team. Before coming to Stanford in 2021 to pursue a PhD in Buddhist philology and philosophy, he worked, studied, and taught in Asia for many years, where he further developed his extensive technical background across several areas of study. This project is a long-running service at the Stanford Libraries, where faculty are invited to engage with our team in exploring computational approaches to analyzing and visualizing data, as well as creating affordances for interactive exploration of that research. We have at times referred to these projects as lighthouse projects, our hope being that our collaborations can help to expose new pathways of scholarly inquiry that could only be possible through such long-term engagements with the associated provisioning of dedicated technical resources. And then a quick overview of our talk will follow this structure. We'll have Michael start by presenting the project's problem statement. Peter will then describe some of the exploration of human pose detection, action identification, and facial recognition models that led to the development of our platform. Simon will walk us through that platform, the MIME platform. Peter will return then to show some of the... hopefully Peter will be able to return to show some of the results that we've obtained thus far. And then Michael will finish us off with sharing his implications and future work for theaters and performance studies. So with that, I'll ask you to come up here,
Mike. So I'm going to talk a little bit about the kind of question that we started with. And, what we began by looking at was pose and staging. And these kinds of elements of theater are really interesting because they lie at the intersection of authorial intent and directorial vision. And pose and staging are also kind of shaped by the design choices that the lighting designer and set designer make, and ultimately mediated by the performer's body and the choices that the performer wants to make. So examining pose and staging can be challenging because it sits at the heart of artistic expression in the theater and is also so common and fundamental to making a theatrical performance that it's almost ignored. Our research question was this simple one: how can we quantify and analyze the physical arrangements and movements of actors on stage to reveal meaningful insights about the director's contribution? And to answer this question, we turned to computer vision algorithms capable of detecting precise poses of actors for every single frame of video in an archival production. Our methodology involved running pose detection on numerous archival videos, which would generate hundreds of thousands of poses, and then sifting through that pose data in order to draw meaningful conclusions. So Here's some examples of archival video productions that we would then kind of pull and generate this kind of very specific pose data for every single moment of the show. And in traditional theater studies, the concept of pose is often taken for granted. Directors, performers, audience members kind of intuitively understand the power of a well-crafted tableau or a precisely choreographed sequence. In theater, certain iconic poses or choreography can define a production, like Brecht's silent scream choreography in Mother Courage. You can think of Bob Fosse's shoulder rolls and arm pops from The Pajama Game, or the collective poses of an ensemble in a chorus line. These kind of indelible poses help make the work memorable and can lend themselves to be a signature of a particular director's style, or be an indication of the way that a director contributed to a production. But these kind of memorable poses are just the tip of the iceberg. Our challenge that we set out for ourselves was to understand the aggregate effect of every single pose throughout a production, and even more ambitiously, to look at multiple productions by the same director or different interpretations of the same material by different directors. In this way, this approach kind of brought us closer to identifying the director's contribution to pose within the theater. And we started kind of looking at the sort of somewhat outdated theory from film studies called auteur theory, which provides a framework for understanding a director's unique imprint on their work. And film is different, right? Film directors have a range of tools at their disposal: camera angles, editing techniques, lighting choices that make their stylistic signatures more readily apparent. And in the theater, the director's expressive capabilities are constrained, and their contribution can be kind of elusive to pin down. In the theater, the director is constrained by the physical space that they're staging in, the fact that their work happens in real time by live actors who can mediate the director's staging. So this is where a kind of big data computational analysis of pose in the theater became interesting. By leveraging technologies like pose estimation and action recognition, we can begin to quantify aspects of a theatrical performance that were previously left to subjective interpretation. We can analyze not just individual poses, but patterns of movement, spatial relationships between performance, even the rhythm and flow of a production. And we can, as Peter will discuss later, use pose analysis to distinguish between the work of different directors, regardless of actors or performance text or design. In this way, we can kind of move closer to understanding the specific contributions that a director provides. And this is important because a director's work is often occluded. It's rarely mentioned within theater reviews. And most importantly, I'd say by several funding agencies, it's considered not a generative art form, but rather an interpretive art form, and thus not worthy of funding. So the question you might be asking yourself is, well, a purely data-driven analysis might pick up on patterns and consistencies in a director's work, but does it capture the nuanced thematic use of poses that a trained theater scholar might recognize? And this has been the delicate balance that we've been trying to strike. On one hand, this technology does have the potential to uncover patterns and stylistic elements that might not be apparent to the naked eye. And on the other hand, we kind of risk reducing the rich and complex art of theater direction to a series of data points. So our solution has been to kind of come up with a synthesis of approaches that, by combining the insights of traditional theater scholarship with the analytical tools of computational methods, we can develop a more comprehensive understanding of pose in the theater. We could use data to support and enhance our qualitative analyses, and we can use our human understanding of theatrical context to guide our interpretation of the data. And ultimately, the problem of pose in the theater is not just about understanding physical arrangements on stage, it's about decoding the language of movement that directors use to communicate their artistic vision. And it's really about recognizing patterns across productions that might reveal deeper truths about a director's style or preoccupations. And most importantly, it's about opening up new avenues of creativity and analysis in the world of theater. So I'm going to turn things over to Peter now to talk a little bit more about our methodology for selecting these pose models and our approach to analyzing theatrical productions.
All right, thank you. Thanks so much, Michael. Yes, we're here in the methodology section. Yeah, I'll just emphasize that one key objective of this project has always been to work with standard 2D moving images taken with regular cameras, so you don't need any special 3D depth data or input from motion capture dots or wearables, which, if it works, opens up the entire history of theater on film for us to work with. On the other hand, this can be quite challenging, especially within the wild stage video, whether it's live on stage or in a studio. In any case, you have multiple cameras, cuts, occlusions, shadows, and really this wasn't possible until about 2018, when advances in convolutional neural networks for computer vision led to the OpenPose project from Carnegie Mellon. And these approaches did improve over the last 5 years, but wake up the mouse here. They did improve over the next 5 years, and they worked well enough for environments, controlled environments for maybe TikTok videos where everyone's more or less in the frame the whole time and it's just a couple of people. But as you can see from this image on the left here, the model still struggled within the wild videos. And this is actually a scene from a Stanford Theater and Performance Studies main stage production of Julius Caesar in 2023, directed by the illustrious Michael Rao. And so the initial models that we were using, these convolutional models, were not doing very well. And they were even worse at estimating 3D coordinates and tracking multiple people in the shot. So when we started this project, we were basically hoping that better models would come along. So and as sometimes happens in this current era of AI research, we actually did pull off the equivalent of jumping out of the plane and having someone toss us a better parachute on the way down. And the parachute came in the form of some new tools and models from actually a group across the bay at UC Berkeley. And it's particularly a group we learned about while attending the 2022 HAI Spring Conference, specifically Angju Kanazawa's group that she directs, and some of the students also work with Jitendra Malik at UC Berkeley. So the most crucial of these tools has the acronym of FELP, and you can see what the acronym spells out. And this achieves what I think is still basically state-of-the-art accuracy for pose estimation. Although if that's changed in the last few months, please let us know. It certainly can. And it does this by interweaving the tasks of estimating human forms but also taking a kind of the appearance. It actually does texture mapping of what each person is wearing, basically, and tracking their trajectories in time in a 3D space, an estimated 3D space, which is just much more accurate at doing things like handling when people walk in front of each other. And so just a little bit of background that most of us are probably aware of. These models derive much of their effectiveness from the transformer architecture, which more or less emerged in 2017, and we're familiar with it from primarily its contributions to language models and large language models. It's the T and GPT. What we're benefiting from here is the advent of vision transformers, which apply more or less the same multi-headed self-attention techniques to images, and specifically to patches of images the images are kind of broken up into words. Here's some further illustrations of how the FELP tool combines not just a vision transformer, but also a separate temporally aware transformer to track poses over time, and also keeping track of pose joints and surfaces, and as well as even the camera position, because you need that to estimate a 3D environment. And so while we're talking about our model zoo that we're corralling here, another model that we used is so in addition to a 3D pose tracking, we also are employing an action recognition tool, more or less from the same team at Berkeley. You can see the acronym for LART there. The Lagrangian piece means that rather than, the standard approach for scene description and action recognition tends to be just describing what's happening in the entire frame. But LART, follows each person, each tracklet, throughout the shot and provides a separate, distinct action vector and also a description that's mapped to this taxonomy for each person in the shot. And we actually find the numbers in the vector is much more useful than just the words standing, watching, talking for the kind of analysis that we do. And a final tool that we adapted for this project actually was not from Berkeley. This is from Google and Caltech. It's an embedding model for 2D pose coordinates, but it projects those into a probabilistic space where poses that are probably similar in 3D space are close to each other. We actually do already have lifted 3D coordinates from the FALP tool, but generally we found that working with embeddings gives you a lot of advantages actually for classification tasks, and it's fine to work with a 2D, sort of these 2D plus embedding instead. All right, now I'll turn things over to Simon to give us a walkthrough of, so those are the tools that other people built that we have adapted, and now we're going to talk about the tools that we actually built to make sense of this theater data.
Thanks, Peter. Pardon me. So to allow us to experiment and work with these different techniques and models, we built a platform that supports development and allows us to make this work accessible to Professor Rao and to other researchers. And it's really the platform that allows us to construct pipelines for processing and running inference against videos of theatrical performances. It's a place where we can experiment and evaluate different approaches and technologies. And we're also able to incorporate new developments as they arrive. For example, the shift from open PIF-PAF, the convolutional model that Peter mentioned, and to the transformer-based FALP model. Furthermore, the platform allows us to interrogate results, and we can use things like similarity metrics, nearest neighbor search, clustering, and we can visualize and explore the various data that we're able to produce. So this is a diagram of the platform as it currently exists, or more or less as it currently exists. It's somewhat loosely coupled, and this is part of what allows us to easily swap in and out different parts. The hub of the platform is a vector database where the results of the lengthy and expensive inference and computational tasks are stored for retrieval and analysis. We did look at bespoke vector databases, things like we looked at Pinecone and Weaviate and so on. But even though it was fairly new at the time, we went with the PG vector extension for Postgres that some people will be familiar with. And that's a choice we'd make again, in addition to all the benefits of working with Postgres, the fact that we're already familiar with it and so on. It's actually, the PG vector has been really good for us. It offers an array of in-engine similarity metrics, different approaches to approximate nearest neighbor search indices, lots of different ways we can do that kind of stuff. And performance has been great. The numbers change as we add and remove performances from the corpus. We currently have around 20 million embeddings in the database, and at this kind of scale, vector search is not our bottleneck. If we had a much bigger corpus, that might be something we'd need to reevaluate. The wrong button, pardon me. So the application and inference server is a container that has all of our machine learning dependencies available. So this is CUDA and so on, as well as OpenCV, FFmpeg, the kind of things people are probably used to. And it's where all of our machine learning and backend code runs. The experimental nature of the project means that this is a big old container. We have a full Python data science stack available, a full machine learning stack. We've got TensorFlow and Keras libraries, as well as PyTorch and scikit-learn, DeepFace, and so on, and all of the domain-specific tools and tool chains that Peter mentioned just a few moments ago are existing in here for us. The container also runs a Jupyter Notebook server that I'll talk about later because we think that's quite useful. And it also runs a fast API server that exposes the endpoints for our web UI. The web UI is currently internal facing, and it's a researcher tool that we use within the team to help us to understand the data that we're collecting. Nothing's exposed publicly at this point. It's built with Svelte and Astro. But in the process of working with this, we've learned an awful lot about how to best present and interact with the data. And we're currently developing a Mark II interface based on SvelteKit that we'll talk about a little bit as well. The notebook and the UI server are behind a reverse proxy that makes everything available to browsers. The whole thing's orchestrated in Docker. This makes it really easy for us to deploy the infrastructure across platforms. We have Mac and Linux developers on the team, and it allows us to use the same containerized environment across the inference and experimentation cycles, which is really useful for developing this kind of stuff. And we can also do training in that environment as well. And we know where we are. We can just deploy it, fire up a notebook, get hacking against the replica of the production environment. So let's take a look at the interface itself. There we go. Okay, so this is the main screen of our the initial screen for our interface, where we have a table of recordings that have been ingested into the platform. The corpus of performances we have available at any given time varies as we add and remove things based on our current interests. At present, there are 11 recordings and about 7 million poses. Tracks over here refers to There we go. It refers to the number of appearances of a figure or an actor who can be tracked across frames. So for example, in Julius Caesar, we have something like 600,000 poses, which map to almost 3,000 tracks. So that's 3,000 unique sequences of the same figure moving through the same camera shot. So let's take another look at the Julius Caesar performance directed by Professor Rao for TAPS in winter 2023 and see if we can see how the interface works. Primary interface to the generated data set is oriented around a timeline chart. Here we have a time series along the x-axis and a number of metrics of interest are plotted along the y-axis. In the first place, we have the track count, as I just described. It's the green line across the middle, of course, and it represents the number of actors detected in the frame. We also have a face count, where we run face detection. As would be hoped, this tracks the tracks quite closely, follows quite closely. Where there's a discrepancy is typically where we have a figure who's in the frame, but their face is turned away from the camera, or they can't otherwise be recognized by the face detection. Towards the end here, we have this is the curtain call, where all the actors are on stage at the same time. They can all be recognized easily, their faces can all be recognized. So that checks out. That's a sanity check for us. Okay, we have an average score metric, which is the confidence score provided by the pose prediction model, can help us to find places where we have interesting artifacts. The pink lines represent camera shots. There's lots of different camera shots and scene changes in this particular recording. The Mind platform also derives metrics for us that represent the movement of figures on the stage and what we're terming pose and action interest. So these are measures that the degree to which individual poses and actions in a frame differ from like baseline or typical performances for that performance. And these kinds of tools can allow us to zoom in on areas of performance that are particularly interesting. So here we have a 5 or 10 minute section that represents the assassination of Caesar. And we can zoom in and take a look at that. I'm going to find a particular frame. I'm looking for 95733, which is, there we go, close enough. And we can see here that the pipeline's done a good job of picking up the 7 actors that are on the stage in this particular frame. We can see Caesar on the floor in the middle, Simba to his left, at the top of the stairs, that's Brutus. And at the front of the stage, on the right-hand side of the frame, is the figure of Cassius, who has the back to the camera, back to the stage, the audience, pardon me. They're walking away from us and they're walking towards the body of Simba. So let's, Caesar, pardon me. So let's go have a look and see if we can find similar poses. On the left here, we have a 3D reconstruction of the pose. And next to that, we have the source pose itself. Here we go. And to the right, we can see the number of different matches that we can find. These are the top matches across the recording. The small cutouts are very difficult to see, especially when there's not a lot of contrast in the footage. And we can draw pose diagrams over the top to make it a little easier to see what's going on. And we can see now that we've found a number of other parts of the performance where we have a figure in a similar position. They have their back to the camera, they're walking away from us. If we return to the timeline, we can see where the similar matches occur throughout the performance. We can see more at the beginning of the performance than at the end. And that can help us clue into different parts of the performance where different things are going on. The platform allows us to work with and evaluate different similarity metrics for our searches. Here we're going to search the view invariant embeddings that Peter referred to. This allows us to find people in similar walking poses, irrespective of their orientation with respect to the stage or to the camera. So we can see now that we can find figures who are walking in different directions with respect to the audience and with respect to the camera, but they're performing that similar walking pose. And so this opens up the possibility to sort of remove that aspect of the that aspect of the detection. Okay. In addition to pose similarity search, we can also search for similar actions using the LART technology that was described in one of Peter's last slides. We're still working on this. It's experimental, but it's interesting to see that already we can return different matches that are surfaced when the additional movement context is part of the equation. We will be doing more with this. There are more opportunities here, I think. We have a 3D scene toggle here, which allows us to reconstruct the scene, or the frame in particular. The 3D predictions provided by the pipeline allow the platform to present a visualization that represents the positions of the actors with respect to one another. These data support lots of different kinds of analyses, some of which will be discussed later on. But again, we can see Caesar on the floor here. We have Simba, Brutus at the back at the top of the stairs, and the pose we were just searching for, Cassius in that pose, is here at the front. So these are some of the affordances that the timeline view offers for us, but we do have other ways of looking into this data, and we'll look at a couple of those now. Clustering in various different ways is always useful. And so the faces interface here presents a dot plot timeline It presents clusters that have been identified by face recognition, and it shows where recognized faces appear during the performance. This is also very experimental. We were hoping we could use face recognition to augment the actor tracking, the primary goal being to tie together tracks that represent the same actor in different scenes or different shots. It hasn't worked as well as we'd like, mainly because the quality of the face recognition that's available to us is not terrific on footage of this kind. There's just too many parts where people aren't facing the camera and so on. We'll need more here, but we have ideas about how we can improve this technology. Okay, we also have a pose cluster visualization that presents a similar chart. Shown here are 15 groups of poses that have been clustered on the basis of a similarity metric, and they're shown as they're distributed, again, across a timeline. In addition to different similarity metrics, there are also lots of different ways we can perform the clustering. What we're seeing here is the result of a very standard UMAP algorithm for dimensionality reduction and HDB scan for clustering, which people will probably be very familiar with. Cluster 15, down at the bottom here, just dropping off the bottom of the screen a little bit, is a cluster of seated folk. There it is. And so we can see that cluster as it's represented across the timeline at the top. So we expect to find seated people here. Here we have a little group where director Professor Rao has Brutus sitting on the edge of the stage at this part of the scene, so we can see a little cluster of shots of Brutus sitting there. Another way of exploring the clusters is with the pose plot explorer, which folks will recognize as a modification of the fixed plot explorer from the LDH lab. The cluster examples are over here on the left. These are our exemplars. And if we look towards the top left of this plot, we'll see that cluster number 15 of seated folks that I was just talking about. They're up here, there we go. And we can zoom in and take a good look and see particular exemplars of that cluster. So over here, we have a group that represents Lucius. Lucius is sitting down with hands on the knees, leaning forward in this cluster. And we can find examples of that. And if we go up and to the right a little bit, we'll find another cluster of the same actor in a very similar position. But here they're leaning back more, their hands are in the lap, looking to their right. It's the same scene, but we've got a different aspect going on. There's also a cluster down here, number 14, of figures who have their right arm straight and their left arm bent, perhaps in a pocket. They're turning to face, to open their body to the audience. We've got Cassius again, we've got Casca, and I think Mark Antonius is down here too. The Post-Plot Explorer also allows a timeline-like view, which is sometimes referred to as a skyline view, where the poses are binned and stacked and distributed across the timeline, so we can see where in the performance these different clusters of poses appear most frequently. And it allows us to get another sense of how that works, how these things are distributed across the performance. So that's some of what we have in our Mark 1 interface. I do want to quickly show our Mark 2 interface and how we're building on and improving what we've got. Here's the search interface as we see matches for that same pose we were looking at earlier. As you can see, this is still a work in progress, but this presentation makes it much easier to see the actors, even if the contrast is still sometimes an issue, so the pose overlay is still a very useful thing to have there for us. It's also easy to get a view of the whole frame for additional context so we can see what we're looking at. Searching by all the available similarity metrics is still supported. Here we are searching by the view invariant embeddings again. But the main focus of the new interface is to allow us to operate across different performances. So here you can see we're searching for that same pose again, performed by Cassius and Julius Caesar, but now we're searching matches for across the entire corpus of productions available to the platform. And this allows us to do all kinds of different comparative work, a lot of which we'll talk about in what's to come. One thing that started out as a bit of fun, but has proved surprisingly useful, is the search by webcam feature. So here's one I made earlier. A frame is captured from a webcam. The inference is performed client-side in the user's browser to produce a pose vector in the form we need, and we can then search the MIME database for matches. So here I've performed this pose for the camera. I'm searching in Julius Caesar, and I've got these wonderful shots of red-handed Brutus at the front. And we can see here how these are distributed, and we can have lots of fun with this. My kids love it. We can also search across the entire corpus as well, so we don't just have to search an individual video. So here are those matches from Julius Caesar again, but augmented with some other matches from other recordings that we have ingested into the system. Okay, last but not least, the Mark 1 interface provides a direct link to the embedded Jupyter server that I will touch on very quickly. I want to mention this because it's been such a useful thing for us. It allows us to very easily spin up notebooks where things are running remotely in the same containerized environment where inference and analysis is done. It's the same hardware, the same dependencies installed and available, the same interface to our embedding databases, the same data set. This is extremely convenient for prototyping, experimenting, and just for noodling around, as well as for conducting more formal analyses. Peter's going to share some of the early results of some of those formal analyses for us in the next slide.
All right, thank you, Simon. Yes, yeah. So I'll just jump right ahead to some of the in cultural analytics, we would say distant viewing analyses, mostly distant viewing analyses that we have pursued using the data that we've extracted, using from the MIME platform, So a lot of this was done using the Jupyter Notebook interface that allows us to have a nice API to get into the database. And here we're again, to go back to Professor Rao's introduction and problem statement, we're approaching this question of what the pose, action, motion, position data that we can extract from recordings with the MIME platform might tell us about how theater directors deploy these elements to produce specific effects, dramatic effects, while also imprinting their own stylistic signature. We focused on 3 high-profile contemporary directors. You could call them auteur directors in theater: Bill T. Jones, Romeo Castellucci, and Krzysztof Radakowski. We selected 10 or 11 performances that each has directed. We used commercial and archival recordings of these performances, and we ran them through the MIME pipeline, pretty much unaltered, although we had to upscale a couple of them because MIME really only wants HD quality or better. So this produced about 10 to 20 hours of pose data per director. And you can hopefully see some of the summary statistics on the table here. So we initially just framed this computational approach as a performance to director classification challenge. So given like pose data or action data or motion and distance data, which elements are most effective at predicting the correct director for a given performance? And we started very simply with this, with just leave one out tests. So we took all of the directors' poses, averaged them all together, and then we compared that vector to all of the poses from a given performance. And whichever director the performance matched was our prediction, and then we evaluated it against the ground truth. So here's some results of confusion matrices. So kind of we binned the input data into a couple of different categories. So the motion and distance statistics was one way of looking at it, which was pretty good at differentiating Bill T. Jones, but not so good at differentiating the other 2 from each other. Whereas if we just looked at the view invariant pose embeddings, that was fairly effective in this basic test to differentiate between all 3. So if we go back to the data table here of all the performances, we've colorized it a bit now to point out the recordings that have higher motion, whether there's also this, you have to make a distinction between in-place motion or sidereal motion, which is moving against the backdrop. And then also we considered interposed distance. So really, Bill T. Jones's corpus really stands out, and that's because he tends to direct dance works, whereas the other 2, Castellucci and Radakowski, are more, in this corpus anyway, represented by stage plays and operas. So we think the motion and distance-based comparison may be cluing more into the difference in genre between the directors, and where the suppose embedding approach is picking up something more distinctive about each director's style. But we'll look more into that in a minute. Here's some more results from using of the same kind of test, but using either the body key point coordinates, the 3D coordinates, or the action recognition vectors. And the action recognition vectors, again, are a little bit better at telling, the vectors are a little bit better at telling the difference between the directors. A lot of this is just because the vector space is semantically partitioned already. So if you're projecting data into that, you're going to get more opinionated results than just considering 3D space writ large. This is sort of a replication test, or we basically tried to expand the leave one out test to be a bit more rigorous, to do some cross validation with different classification algorithms. And keep in mind, 33% is what you'd expect by chance. Interestingly, the Gaussian naive Bayes approach was as within the margin of error anyway, as differentiating directors based on motion and distance statistics, despite what I just said about motion and distance only being good for genre, as the formally dominant distinction that we get from looking at the embedding approaches. We tried many other classification models, many other classifiers, including some fancy neural models, but pretty much got the same results. It is a very small data set still. I mean, in terms of the actual, 31 data points that we're trying to classify, even though it also involves millions of poses. That's what happens when you do distant viewing. So we tried to get a little bit at the question of exactly which elements of these feature sets that the models found most useful, differentiating between directors. So here's some results of feature importance tests and very large error bars, but we do see in some case that we get clues that the motion data is generally more useful than the distance data, at least for this task, or the distance between the actors. That is, we get a sense of which elements of the 16-dimension pose embedding vectors are useful. But of course, what does that mean? It's just a dimension in an embedding, and we'll show it in a bit. What we did to try to dig into that a little bit. One interesting thing, if we consider the 3D body key point coordinates and which ones of those seem to be more salient for differentiating between directors, it's the lateral movement of the right hand is the most, and there's some other interest in than the left wrist or hand. Also, the fact that there's a distinctive right hand and right side bias at least shows us that something's working here, because that's what you'd expect given the human population. And then to explore how the director's pose repertoires might be distributed throughout the view invariant embedding space. We plotted those on, and this is actually a 1% sample because UMAP crashes my computer when I try to do more than that. Of all the pose embeddings in the 2D space, the larger hexagons that are called out there are the director's average embedding. We can't directly generate, we can't directly translate an average embedding into a pose, but we can, thanks to the MIME interface and our vector database, we can search for the poses that are very similar to that. And that's what, to each of those director averages, that's what the callouts are showing here. So we do seem to get some good insights from this. The blue and green, the Castellucci and Velikovsky are generally more intermixed because their repertoires are more similar, whereas Bill T. Jones has kind of his own area, and the callouts highlight how Jones tends to employ these more dramatic contorted poses, whereas Castellucci does seem to have appreciate this the drama of good hunched over pose versus Velikovsky having people sitting at tables doing things. Again, very distant view, but we're getting some clues here. So our final analytical experiment to date, still a work in progress, inverts the previous challenge and instead, has multiple directors, 7 in this case, staging the same work. And in this case, the Don Giovanni. So this is an opera, music by Mozart, libretto by Da Ponte, but direction by all of these directors. So that's the free variable there. So yeah, and you may recall these screenshots from the beginning of the show, from the beginning of the talk. This is actually the same scene as staged by all six of these directors. If I skip ahead here, and so the table gives numerous derived statistics from these performances. That's colorized to highlight the ones actually that have more motion, more distance between actors, and more deviation of their pose repertoire from the consensus, the average of the entire of all 7. So yeah, it's also ordered chronologically. So I think we can see a trend for stagings to get more creative and non-traditional over time. It's as quantified strictly through pose. That's all we're looking at: pose in motion and action. And we did this just to a little bit of behind the scenes. To do this kind of analysis, you need to align every moment of all 7 productions. And we did it. It's actually can be pretty hard to do, but fortunately, Don Giovanni is an opera, so there's music throughout. So we use some old-fashioned music AI to align all the performances based on pitch chroma, pitch sets, and then we just use dynamic time warping to do the actual compensation to give us a nice warping path to align all the performances. And what this allows us to do then is to take all of the attributes at a given moment and average them together to build what we call a consensus performance, or in folklore you would call it the tradition dominant. So it's like the what all performances of Don Giovanni tend towards, but are also struggling against, to find their own forms of originality. So we can do things like, this is actually the 3D movement in all 7 performances, and every frame basically overlaid. But then if we take this approach of averaging out the consensus, we get this data to work with instead. So this is the deviation of every performance's motion at a given moment from the consensus. We also do this for the poses, and so we get this kind of data, which is actually interactive here. Oh, and I should mention these vertical dashed lines are showing our scene breaks in the opera. So if you know what happens throughout Don Giovanni, you can see which scenes tend to have distinctive poses or more variation in poses or motion. And so, like I said, I'm just going to go back. Second. Maybe I won't. But like I said, this is a work in progress. We're hoping that it can detect more patterns, like certain scenes in which stagings are more likely to deviate from the consensus, and we eventually use this to highlight places where directors might use especially distinctive poses and actions. But stay tuned on that. So now I'll turn things back over to Professor Rao.
Thank you, Peter. As you can kind of tell, the computational analysis of pose and action in theatrical performance, as presented, it's starting to open up new avenues for understanding directorial style. And as I said before, this is significant because the creative contributions of directors are often either overlooked or reduced to just a single memorable moment. And in reality, when you're directing a production, the staging is a very meticulous process that unfolds over weeks and months, with the director crafting every single moment of a performance. And by using this technology to examine that work in minute detail, we can gain a more comprehensive view of their artistic vision. And we're still obviously building a whole lot and still trying to figure out what these results could be. But I'm going to talk a little bit about all of the things that are exciting me about the implications of this kind of technology. So as kind of mentioned before, and as Simon showed you, we can use the pose similarity function to start to identify recurring poses, symmetry within poses. And looking at the overall timeline view of a performance, we can start to see the ebb and flow of a performance, looking at the rhythm of a piece, of when actors are on stage and what poses they're in. Using this pose, we can more readily identify common themes and stylistic elements that might define a certain director's creative output. And more importantly, we can start to separate that as their unique contribution, which is divorced from the work of the performers or the constraints of a particular text or physical space. And then by analyzing pose and movement across an entire director's body of work, we can, just lost my place, we can identify recurring patterns and trace the evolution of their style. And these are elements that might remain elusive if you only looked at one particular production by one director. Additionally, this method enables objective comparisons between different directors' interpretations of the same material, which would reveal different dimensions of artistic expression and decision-making. And by comparing different directors' versions of the same work, we can start to see how physical expression and spatial storytelling evolves over time, or across different cultures, or in specific canonical works, look at how a director's staging sort of deviates from the traditional norms. Scholars could look for certain themes or characters and how those are represented physically. An easy topic would be like to look at how kings are represented, to see what poses are associated with power or submission. This technology could also be used to chart how an actor's physical choices could evolve through rehearsal into a performance. Then a scholar might be able to use the rehearsal and performance pose data to study the methodologies of actor training or directorial vision. And given the precision of the timeline view, it's literally frame by frame, we can also correlate pose data to audience response. So based on when an audience applauds or laughs, we can start to see which types of physical expression elicit the strongest responses. And that could deepen our understanding of how audiences engage in the live performance. I am a practicing artist. I am excited about these tools because I could see this enabling new kinds of staging, helping me rethink pose within canonical performances, and also inspiring perhaps innovative uses of pose. And ultimately, I'm excited about this work because it has the potential to create an unprecedented record of a production's physical language, which can be a really valuable resource for future research, teaching, or even restaging. I'm excited about this because the potential seems vast. And as I'm also talking about implications, I also think that this methodology could be readily extended beyond theater studies. Easily, this methodology could be applied to film, to, as we kind of mentioned, opera and dance, and any of the other art forms that involve human movement. Beyond the arts, this approach could be applied to analyzing political speeches or studying biomechanics and physiology in sports. At the same time, as I'm talking about the implications, it's crucial to acknowledge the limitations and ethical considerations. As with all AI, there is the danger of hallucinations, of incorrect pose estimations. There are responsible use considerations when working with archival materials. And so this is a complex ethical landscape that requires careful navigation. And as a team, we've been very clear with each other and developed guidelines and frameworks to ensure the respectful and responsible use of these technologies and these materials. And then from an analytical point, we also have to recognize the limitations of focusing solely on pose and action. Theater is a multifaceted art form, and while pose is a critical component, it represents really only one thread in a very rich tapestry that include things like dialogue, set design, lighting design. And without taking those other elements into account, we risk not interpreting a production properly. So while I'm very excited about all of the computational insights, I always view this as a complement to, rather than a replacement for, traditional methods of artistic analysis. As I've said to the team, the pose offers a narrow but powerful lens through which to view and examine a performance, which enriches our understanding, but rather than supplanting it. And then finally, I think as a working artist, it's important to note that this computational approach can't determine directorial intent. The patterns that this algorithm is picking up may stem from conscious directorial choices or actor improvisations or even unintentional recurring elements. And as such, these findings start as a starting point for deeper and more nuanced investigations rather than definitive conclusions. So I'm wrapping it up. So I hope you can hear me saying that I am very excited about the possibilities of quantitative analysis in the arts, but that its true value lies as a complement and enhancement to traditional scholarly approaches. By integrating these methods with an expert human interpretation, we can develop a more comprehensive understanding of theatrical performance and directorial style, which I hope ultimately enriches both academic discourse and artistic practice. Thank you so much.
Hello. Yeah, thank you so much for the talk. Super interesting. So my question is on the ethics angle, because I'm familiar with AI as a technology in other contexts, and it goes in the classic facilitating plagiarism, monetization issues? Like, for example, do you see that if you use these tools to analyze the theater, then there will be an economic incentive to produce only those pieces of work that reflect certain features? Same for the movies, same for everything. And again, and the other thing is the plagiarism aspect as well. Like somebody could impersonate director XYZ. Have you thought about all those issues? Thank you.
I kind of want to talk about the plagiarism aspect because that's perhaps one of the more interesting things. For a long time, and I believe this is still true, staging is not a copyrightable activity. So again, because people don't consider the director's work to be unique or generative, it is always an interpretive thing. If someone were to plagiarize someone else's staging, while professional practice it is like frowned upon and people kind of shame you legally, it's not a copyrightable thing. And so I think this technology is interesting in order to be able to very precisely look at staging and find those similarities and also start to discuss the minute differences of this. But I don't know, maybe the team has other thoughts on ethics and AI and algorithms.
I'll add something briefly then, just quickly, just to say that I think we always have to be very cautious and think very carefully about how the technologies that we're working on and the techniques that we're making available to other people to use, how they can and will be used. I don't think that everything that we do in this field requires that we give some thought to that. In our particular case, I think, as Michael mentioned, there are specific issues that affect a very small area, or rather a relatively small domain of human praxis in this case. But it is something that we bear in mind, and it's something that we think about with every step.
Hi, thank you so much for this presentation and for the exploration of the technology. My name is Karishma. I am one of Professor Rao's students in the Theater and Performance Studies department. And so it's really exciting to see the intersection of AI and technology play out as a new tool for performance studies. I have a two-part question about the archive and process. The first part of this is, I noticed that a lot of the primary data you used was recorded videos across time and space. I'm curious if this product or if the tool can go beyond the recorded image. And I ask this question to consider performances pre-modernity, I guess, or pre-technology, which haven't been necessarily recorded with a camera. How do we think about extending our archive in that way? And also, in addition to that, could the tool be used in the director's process, say the rehearsal room, for example? Have you considered how it might be implemented on the physical body as it's being performed also?
I invite my colleagues as well to weigh in on this. I'll just say, involving certainly pre-video recording corpora. Obviously, that's a tough tough challenge. But I will say that our work with pose estimation and even the use of the embedding models owes a lot to previous research in cultural analytics, working with images and even visual art going back as long as we had visual art. So certainly, there's a lot of work involving depictions of and deployment of poses across all human traditions. And it's a fun challenge. Those models are even harder to get right in some ways because you're working with oil paintings or cave paintings even, and rather than natural video footage. But it is possible, and that would be a really fun extension of this work would be to consider sort of this. It is a growing body of research that is becoming pretty sophisticated and applying sophisticated approaches to this idea of quantifying the prose repertoire of the Renaissance, the prose repertoire of Baroque period. So that would be one way we could definitely look into that. Did folks have other
One thing I can add is that early on in the project, we talked about both looking at videos, but also looking at live performances. And so were we to be able to get a rig set up on stage where you could have a near real-time inference, then that could be of great help to the director. That could be of help to the actual actors as they work through the performance with the director. So we really moved into an analytic direction instead, but that's something that's always kind of in the back of mind. And you see that happening right now, right? There are performances, right, where live video feeds are run through an inference and displayed on a screen for the audience's pleasure, or also for the actors to then respond to.
I can talk a little bit about my own artistic practice because we've been working on this since 2023. And I've been thinking a lot about pose and analyzing my own work through these things. And there's a slide that we didn't include where I realized that compared to some of the other people in the archive that we have, my work is far more boring and less interesting than perhaps some of the great directors whose work has been recorded. And so it has put like a different focus for me as an artist to be like, oh, geez, I'm not going to let people stand around so much. What if you hunch over and put your left foot out, you know? So yes, it's starting to change, or certainly the tension that I'm placing on it between the rehearsal room and the kind of, I don't know, scholarly study that I'm doing has started to affect the way that I'm thinking about my work.
I'll just add one more thing. I know we've probably got other questions, but one thing that we did consider that we haven't looked at was the idea of recording successive rehearsals across the run of a play. That was one of our early ideas and something that we still would like to go back and look at. If you had recordings of rehearsals and see how the play develops over time, you can have the advantage perhaps of making a fixed camera and all the kind of things that would make some of this work easier. You could see perhaps how performances developed through the course of rehearsals to the final production, and perhaps across the run of production.
Oh, I'm curious, actually, related to what you said. How, given the constraints of the stage and the human pose, how big is the space you're working with? You know, like, and as a actors often have a very interesting physical presence. So I wonder whether you're running out of space in terms of what you can try, or whether it's one of those situations where there are more stage productions than there are atoms in the universe kind of thing.
Sure. I mean, I can start. You know, people have been making theater since 2000 BC, and it seems like we're constantly still coming up with stuff, or at least for me, I can think about my staging in relationship to the works that I've seen before. And so, sure, there's only so many things your arms and legs can do, but putting that up against the particular text, the particular bodies, the particular story that we're trying to tell, the uniqueness of the actors, the design choices that people are making, I find it, you know, there's still interesting things that I discover each time I go into the rehearsal room. So I think most directors would say there's still a whole lot more to be discovered.
Briefly to that in terms of the range of degrees of freedom, it's important to remember that not only are we talking about poses, we also have the ability to analyze actions and the way poses change over time, and that dramatically increases that space for differentiation. Where we have performances that have a lot more movement, so we have looked at some dance stuff and some other things, and they obviously are more challenging in some ways. They also produce greater degrees of movement and so on. But as we have a big enough corpus, although there is a somewhat restricted space in terms of points of articulation of a pose, when you add in the time dimension as well, we don't need huge corpuses to produce statistically significant differences in different subcorpora, for example. And so those approaches are surprisingly useful. And the bigger we can make our corpus, the more we can make use of what is, you know, apparently restricted space in terms of dimensionality.
Yeah, I think Michael and Simon covered most of it, I'm sure. Yeah, just some extra wrinkles there we could add. Certainly, what was I going to say? Yeah, it's a valid question. You know, of also, there's a question of the resolution of the models. How much are we sampling the noise if we try to go into really subtle differences between motions? But you know, the models are getting better. The cameras are getting better all the time. You might have noticed everything at a certain point, the models tend to kind of abstract back to like this 13 key point pose, just because that's what other models assume, and you're trying to be, you know, compatible with. You have to be compatible with various layers. So obviously, bringing hands back into the models, which we don't really have right now, you know, gives you a whole lot more to work with. We have hands at one level, but then we throw that away later, and you know, more facial expression. So there's that's sort of the almost a fractal nature of to use a cliche, data cliche, of cultural expression and what's happening on stage. And yeah, so then that's just considering still poses. And as Simon mentioned, we have action data as well. And yeah, we sort of abstract out, or as its own domain of analysis, motion and distance on stage. There's still, in my mind, this weird disconnect between the idea of a gesture versus a pose versus an action. You know, action recognition models, which are, you know, trained on thousands of YouTube videos that have been painstakingly tagged, are good at getting at this kind of amorphous idea of an action that you sort of, you know, you make the neural network enforce a set of labels on, and that's what you're working with, which is great. But for me, I think the one of the holy grails is sort of having a generic general purpose gesture recognition system that can actually segment semantically meaningful gestures in interesting ways. And this is maybe it's not a real thing. Maybe gestures don't actually exist. You know, this is one a philosophical question we run into, like when Apple says they do gesture recognition to help you control your smartphone, they're doing pose recognition. There's no, or maybe there's a little bit of gesture recognition, which is just like moving your hand over this way, you know. So there's that. But you know, you kind of have to know what you're looking for in that case. So the whole dimension of sort of unsupervised action and gesture recognition is, if we ever ran out of poses to analyze, it's something we could spend another career working on, basically.
Great talk. I really enjoyed it. So it's fascinating actually to see how technology and art can intersect. Very interesting findings. So there are really, I have two questions. One thing you mentioned that you were considering comparing evolution when you start practicing, and then, because my question that I had was, how much of a style really is attributed to a director as opposed to actor? Because you know, some actors have their style, etc. And then you can really see whether a director is molding, shaping actor, or how much of an impact there, right? And another thing is, we know that it's a cultural, like cross-cultural issue. We know that in some cultures, different gestures have different meanings. So it's kind of like you have to be careful. So looking at that dimension to see how much of an impact, whether you have, for instance, a performance for a particular target audience, do you actually have some variation, how much you adapt? So I don't know whether you have given any thoughts to this and how this can be expanded. So I think there are a lot of fascinating uses for this.
So certainly within the theater studies world, there is a kind of assumption of a particular director's style, regardless of the contributions of the actors or the script, right? Like there are certain directors who most theater scholars will say, like, yes, Robert Wilson has a very unique directorial approach that is recognizable across regardless of who he's working with or even what text he's working on. And I think you can see, I think one of our questions is, can we see that in our pose data as well? You know, which would basically just try to replicate the work that a theater scholar already does, but as a kind of gut check to make sure that, yes, we are seeing the same poses and understanding the same sets of datas. And then, yeah, the question of cultural work, you know, almost all of the work that we've been working with has been like European canonical works. But that's just kind of a function of which recordings we have access to and what we feel okay using. Certainly, given recordings of different productions from different cultures, we could absolutely kind of both look at the comparisons and differences. And I think that's just a whole other future area of research to kind of explore and do. Yeah.
And also just to speak briefly to the question about like tracking changes into performance over time. I'll just point out, which I could have acknowledged during the talk, that the tools from UC Berkeley, all the use cases were really sports analytics. You might have noticed that, and certainly we could probably borrow some techniques from that practice as well when we're critiquing how, or just tracking how an actor is developing a performance over time.
It's a great exploration you guys are doing. I immediately was thinking about the mental health or just medical aspects of being able to, say, baseline someone's gestural behavior. You know, your mood goes up and down, or just you could also, if somebody has a crisis or an issue, you might see, you know, they be classified in a different way. Anyway, any thought of finding somebody at the medical school who might be interested?
So we've taken these models and applied them to theatrical performances, but I think there's a history of where these come from, and there's lots of initial use cases. There are state security and surveillance types of technologies that this was developed for autonomous vehicles, analyzing poses, right, as they drive down the street, and is this person walking in front of me or walking away from me? But I do believe there are medical AI projects already looking at this. I'm not aware of them, but there's innumerable applications of these models, right, as humans. And I think there is work. If I can find any, I can take your name later. I feel like I've heard them happening here at Stanford. Yeah.
Thank you. Thank you so much for coming.
Thank you all.